So if you are working with enzymes, so this is well established in terms of glucose, but unfortunately if you're working in a lab, you've ever tried to order enzymes, you can see there's a lot of variations in the enzymes that you get. There's also shortage of supply. So our aim is to develop a method-based approach that can be used for molecular techniques. So what we'll show is that they're just as good in terms of detection, much more stable, much more robust, and it will show that they can withstand extreme conditions unlike enzymes. So what did we do? So we developed a novel polymerization approach, so oxidative polymerization used for glucose, where we developed electroactive nanoparticles. So these nanoparticles were immobilized onto screen-printed electrodes. Here you can see that these nanoparticles are nice and round and homogeneous in shape, and we looked at the binding glucose. So we did very simple cyclic photometry. You can use other approaches as well, but you can clearly see as soon as you start incubating with glucose that you see a rapid drop in the signal. So there's a quenching when you add glucose. So glucose is present in quite high quantities in the body, so actually millimolar, which normally for targets we're looking at much smaller ranges. But actually the nice thing of our sensor is that we can go really low, but we can really measure across the spectrum, so even to really high concentrations, which is quite unique. Now, the interesting thing is normally people use like a standard 3-electrode system, but we showed that we can also work on a 2-electrode system, which is interesting because then you can start thinking about a wearable when you don't work with a 3-electrode system. So this is our limited detection, so you can see we measure in a really wide range. We looked at some selectivity experiments, which are not included here. We looked at some non-imprinted particles as well. But what's particularly interesting is, and if you look there, we can expose it to a wide range of temperatures. So the elevated temperatures, we show that these particles still work. And actually, because it took quite a while to get this published, we actually took the particles, made the sensors, left it in a cupboard for a really long time. And you can see for up to a year, there's still very good response of the sensor to this. So that also means that you can use it in a wide range of conditions. So overall, since then we've actually used this approach for a range of other small molecules. So it's not just glucose. We can get very quick response within like 30 seconds. We can go down to low nanomolar concentrations, but up to really high concentrations as well. And we're looking now at applying this with industrial partners to non-invasive sensing, so we're looking at interstitial. Thanks very much.